Hello, Maurieo. In this video, I'm going to be looking at a classic circular roundabout and just going to do a bit of investigation there as to the area of various aspects of that roundabout. In particular, we want to find out the area or the sealed area of the roundabout, the area of the traffic island, and perhaps the total area of the roundabout. Just looking at that, we can see that the traffic island is a circle. We're given the diameter there, so we know that there is a formula for the area of a circle, and we can work that out pretty easily. The larger circle here, similarly, we can work out the area of that, and then to get the area of the seal, of course, we would take the smaller area of the smaller circle away from the area of the larger circle. Now that's all very well, and I have here been given some dimensions. I've tried to look at this investigation as to solve all of the problems for any sort of roundabout of any shape and size, rather than just dealing with one particular one. I thought I'd use an Excel spreadsheet to show how we could perhaps investigate, in this instance, by using various widths and what have you, the possibilities of perhaps optimizing the area or costs and prices or whatever, and looking at various trade-offs. So anyway, let's have a look at how we're going to do this. So the first thing we probably need to know is we need some formula and stuff. Now the area of a circle is pi r squared. Pi, of course, that one of the major ratios of mathematics is the ratio of the circumference of the circle to the diameter. So if you measure the circumference of any circle, no matter how big or how small, and divide it by its diameter, then you do that very accurately, you will get pi. So just remember that. It's the ratio of the circumference to the diameter. Doesn't matter how big the circle is or how small it is, the answer will always be pi. Pi is a rational number. That's an irrational number. It cannot be expressed as one integer value over another. It's very irrational, pi, and so this means it has an infinite number of decimal places. So the area of a circle, pi r squared. R being the radius, and the radius is 2 times the diameter. Here's the diameter. The diameter being the chord of a circle goes from one side to the other and passes through the center. So the diameter, if we know the diameter, we divide the diameter by 2 to get the radius. And here we've got just the width of the bit of a road here. So you can see that if that's the diameter of that circle, the inner circle, the diameter of the outer circle would be D in this case, plus 2W, one there and one there, to give you that diameter. So here we are. We'll start with the traffic island here. And I've shown these boxes here as yellow. They're input boxes. So if we want to work out the traffic island area, we can put in our diameter, and I've got it here as 24, but we might want to put it in as, say, 12. And you can see that everything changed there in the spreadsheet. So that would give us a radius of 6 meters. A circumference being the distance around the outside of the circle, can also be referred to as the perimeter, but with circles usually circumference. And then it calculates the area of the circle. Here let's just have a look at the little calculation here. So it's E14, which is the radius, raised to the power of 2, so r squared times pi, and this is pi here in the thing there. So we're just doing that in the Excel spreadsheet, and that gives us the area of the traffic island. The area of the roundabout, and I've got that down in here. I've just got the little formula in here. D plus 2W will give us the area of the diameter of the large roundabout circle. So there you can see there, and if we push the F2 button, you can see it's D14, which is our width. Our diameter. Our diameter here, D14, I believe. Yes, there it is there. D14 plus 2 times C16, which is the width there, and that gives us the diameter of the larger circle. Divide that in 2 to give us the radius. Circumference is 2 pi times the radius, so we've worked that out here, and then that gives us the area of the larger circle. Now, to work out the area of seal, of course, here we just take the larger one from the smaller, and that's what we've done there. Just F2, as you can see that highlighted in blue, G16 minus G14, all in an Excel spreadsheet. And the beauty of this, of course, is if we want to change our traffic island to a 10-metre diameter and the width of the road perhaps to 5 metres, we can see here the various effects that'll have, how much seal we need. We can then probably in another column we could put some costs and costings against that and work out what the optimum width to diameter ratio might be based on any number of things. So there you are, maurieo's circular roundabout investigation.